All right, this is part 2 of our lecture on Unit 1 and blueprint reading. You see example here again. We ended on care of blueprints. I want to kind of reiterate a little bit. It is our responsibility to take as good of care of these as possible because it helps everybody to be able to read and see and understand clearly what the design intent of the print is. So we don't want to wad them up, crinkle them. Folding blueprints is perfectly fine, but we do want to be careful as we unfold them not to tear them. Again, a lot of these things have changed from the time I first started reading prints and 30 years ago, and part of that is because of the usage of CAD and the transfer over of a lot of companies to CAD systems. And I think a lot here locally, a lot of the manufacturers are predominantly using computer systems for employees to look at and read prints as opposed to actual paper copy prints being out on shop floor. Now, one of the reasons for doing that, of course, is quality management systems and the idea that of controlled documents and quality management systems. If it is in a CAD system, we can control a lot better who's able to see it, who's able to make changes to the print, and we can kind of protect and safeguard that print a lot more in a computer-based system in terms of quality management. One of the problems with paper copies is a lot of times is, those paper copies can make it out the door. People can carry them out. Of course, if you're talking about some espionage type stuff that, companies want to protect their intellectual property, and I've had to sign non-disclosure agreements many times in terms of blueprints and making sure that I would protect the company's assets and not convey or share this information with anybody as well. So, and I would imagine that some of you will have to do the same thing. Now, so that's where we are talking about. Again, 30 years ago, we used print cabinets. Size A and size B prints usually wouldn't be folded. They would be laid flat but any type of size C, D, or E drawing would, of course, get folded so that it could fit neater in the file cabinets. So usually on those, they weren't the originals. They were generally photocopied or reprinted out type of print, because we knew that in time there would be a wear and tear would occur on those prints. So the next few slides, we're going to talk a little bit about the electronic format. You do need to be aware of this. This is predominantly based more for the people who are creating prints in CAD system as opposed to the people reading it. But do be aware that as technicians, especially in the computer side, we do need to know what these different types of file formats are and how they apply and what you can and can't do with them. Because a lot of times we can manipulate from one file type to another based on the software we're using. And most of your CAD/CAM systems have the ability to do this. So a PDF, a portable document file, is one type. IGES files, STEP files, STL files, and DXF files. Now, a DXF file is what we call data interchange format, and that's frequently used as a way that we can, if we're operating in one type of CAD/CAM system, we can save that and it will be able to open up into another type of CAD/CAM system. STL files are stereolithography files, are predominantly used when we do create a file format. Then the STL files can also be created, and that's what we would need in order to 3D print from, and used for other types of things as well there. ISO is the International Organization for Standardization. So make sure that you are aware of this organization. It's part of the standards. So ANSI is the American National Standards Institute, so ISO is the entire world. ANSI is kind of one of the bodies here in the USA that kind of controls and maintains these types of standards. ASME is the American Society of Mechanical Engineers, and this particular organization is the organization that develops and what we call the Y14 standard, which incorporates. We'll be kind of going through the Y14.1 to Y14.5. And that is the standard on how the actual layout of the blueprint should look. It's also the standard on the application of GD&T, and this particular standard is developed and maintained by ASME. Every so many years, there are review committees and members of ASME that do get together that are experts in this field that review it and either make changes to the standard or say, yeah, it is still agreed upon that we maintain this standard as it is. Now, so I mentioned the standards. Of course, once ASME has adopted the Y14 standard, ANSI also looks at it and adopts it, and ISO on an international level adopts it too. Now, this is a voluntary guide. Companies don't have to follow these standards, and in fact, many of them don't. So, a lot of them do, but they might kind of call it their own thing. So this is voluntary guideline. Now, there are a couple reasons why companies don't, and there are some reasons why companies do. So let's start with the reasons why a lot of companies don't. Sometimes there is training involved for staff, especially engineering staff and manufacturing staff, to learn the standard and know how the standard gets applied. And for some companies, that can be fairly expensive. Other reasons why a company might not be a voluntary guideline is they're an older company. They've been around for 100 years, and they have literally thousands and thousands of prints that they have made, some of which have gone obsolete. Others they're still putting into their products. It would be very, very expensive for them to convert all of those drawings over to accommodate the new standards. So those are some of the reasons why companies might not voluntarily guide or voluntarily follow a standard. Now, for some of the justification, one other reason too is maybe it's a very, very small company or a new startup company that's being done by students or has some professor that is kind of working on this, and maybe they just don't have the background in manufacturing where they're not really familiar with the standard or even the fact that there's standards out there that exist. So that is another reason why the standard might not be followed. Now, some of the reasons why companies should follow the standard is because it does make interpretation and reading of a print much, much more universal. So it does also incorporate and help to make sure and ensure that parts get made correctly. And if you remember in the last lecture video, I discussed interchangeability of parts. So if company does follow this standard, it also helps with making sure that no matter where that part is made, if all of the people who are working on or making that part understand and know how to read the standard, then you're going to ensure interchangeability of the parts there as well. But again, it is a voluntary guideline. Back to the design process again. So a statement of the problem, possible solutions, refined solutions, testing, analysis, and implementation. And I bring this up because, sometimes with the standards, standards change, or even when we are working within them, we do part of the standardization process. It does help us to understand and know, hey, we've got a problem here, so let's go back and let's kind of go through the design process just to make sure that we're getting closer and closer to perfection every time we do it. Just a little quick snippet here of a lot of the different types of parts. You all have seen different parts and now at this point, unless you're brand new to this. In that case, you'll be seeing a whole lot of different types of parts here that are made by our local manufacturers. So I encourage you to really start to look over these different prints that you see on the job as we go forward.